Okay, welcome everyone. Welcome to the MiniDebConf room in Capitol du Libre. Santiago is going to talk to us about Linux stuff, live patching, I don't know. Welcome.
Thank you. So thank you everybody for attending. I would like to start saying that I've been working on this with Emmanuel, who unfortunately is not here. He would like to cross the ocean also, but this has been teamwork, but I'm presenting myself only. So what is live patching? It's also known as dynamic upload or hot patching, excuse me. So it's the application of fixes, especially security fixes, without interrupting the system. We focus on the kernel, and I mentioned that because in theory it could be possible to live patch user space, but here we're talking about the Linux as the kernel. There are use cases that require to maximize the uptime. For example, complex scientific computations that are running for several weeks, critical services where the uptime and the availability is important, or if you want to beat a record of watching an endless video cat, you don't want to reboot your machine. In all these cases, one for the users to ensure that the kernel that they are running got secure, got the updates between two kernel images, updates and installations and that. So, live patching in Debian. The kernel live patching is not something new. It exists since 10 years ago, in 2014. And Debian currently lacks Linux live patch support, and yeah, we are trying to fix it. Why? Because there are users that will benefit from it. Also because it is fun. It's a fun topic, but we are doing seriously. And also we like to state early that we like to give more work to the already very busy related teams in Debian. As any research and development project, we like to look what others are doing. The support for live patching in the kernel is exclusively found in commercial distributions as a service. For example, Red Hat, we don't find too many technical details about it. This is probably based on KeyPatch. We will talk just later about KeyPatch, and the live patches are distributed as RPM packages, it seems so. Also, SUSE, they base their solution on KeyGraft, and they are also distributed as RPMs. I know they support secure boot, and I found it interesting that SUSE is also supporting user space live patching, but it is out of context here. Both distributions started with this almost simultaneously in 2014. Also, Ubuntu provides the live patches service via their commercial offering. I know they are focusing on high and critical vulnerabilities, and I mentioned that because, especially since recently the kernel is, they are their own CNA, and they are issuing CVE IDs for every box. So there are a lot of CVEs, and we are not going to fix all of them. We probably will also focus on important issues. Ubuntu has chosen a specific client service infrastructure, and they are also supporting secure boot. On the community side, on the community distribution, we found that Gentoo tried to make an attempt to support live patch with a project called eLivePatch, but it is installed since 2017. This is also a client service architecture where the client sends a request, a developer sends a request asking for a live patch from a custom patch or for a specific CV. The server builds a kernel model and sends it back to the user. They are using, well, the project was using KeyPatch. And this is a graphical summary of the Gentoo's approach, the Gentoo's livepatch approach. So we will talk later about this KeyPatch build. This is the tool that we are relying on our idea. Also, I forgot to mention that this presentation is of our ideas and of proof of concepts. So consider this above. I'm giving a lot of time for questions. And to the best of our knowledge, there are no community-based distributions providing Linux live patching as a service currently. And we are aware that this is not an easy task. Beyond the distribution, the mainline kernel supports live patching since version 4.0. The live patch model, is it possible to build a live patch model for a regular source code, implementing the new functions and given a structure that relates the functions to be replaced with the new ones? For example, this is the code found in the kernel, where there is here with the kernel live patch function, I'm going to replace the command line proc show function with this new one, the live patch command line proc show, which is implemented like this. So I'm giving this to the kernel and to compile a KO. So this requires adapting patches. For example, I'm interested in providing security fixes that commonly comes as git commits, as patches, and the mainline kernel approach will require to implement the whole function, or to have available the code for the full function. And nearly at the same time where the mainline support integrated the live patch support, KeyPatch was born, and it is great because it makes it possible to create a KO from a simple patch. And they save a lot of time because the fixes that I want to apply come from git commits, from patches, and this is the base for our work. I will show later in the demo how we can do this. And someone from, a fellow Debian developer in the last DebConf talked to me about the key exec. So I did my homework, and this is not what we are looking for because key exec makes it possible to bypass the boot normal process. It speeds up rebooting the system, but it doesn't prevent the system to be rebooted. So this is my answer to my friend. So KeyPatch. We have decided in the idea that we are designing to base it on KeyPatch. This is already packaged in Debian. We actually salvaged the package some months ago. It is included in Trixie currently with the latest upstream version. And KeyPatch relies on modern kernel feature that has been used for tracing, actually. And how does it work? At build time, the compiler injects a no-op at the beginning of each function. And this no-op instruction can be replaced at runtime to call tracing facilities. So the live patch replaces a function in the kernel registering an F-trace handler and modifying the return address to this new function, which is more clear with this figure. So Before patching, we have this here, our function with the neop instruction, and key patch will replace the neop with an ftrace handler to the address of the new function simply. Until now, we have identified some restrictions. For example, the architectures that could be possible to support currently, where there is MD64, of course. Key patch support a couple of IBM architectures, the Power and System Set. And we don't plan to support secure boot in the first iteration of our project, because it's quite complex from different points of view. Is it difficult to apply live patches for changes that change the data structures? It seems there are workarounds, but I need to study this more deeply. It's difficult to replace init code changes. Also, is it difficult to apply live patches for removing references to static local variables, removing code for sure? Yeah. We are relying on key patch, who provides some guarantees, but it doesn't guarantee that all patches are safe to apply. So every patch needs a human review. We are focusing on the kernel, so if you want to keep your system safe, if there are updates for the glibc or other important libraries, you need to reboot anyway. This is the live patch life cycle from the kernel point of view. So live patch needs to be loaded and enabled. The only way to enable it is when it's being loaded. There is a function called patch, the enable patch in the model init callback. And then some relevant entries are created in the file system. Insist kernel live patch with the name and then the name of the live patches. The live patch then enters into a transition state where the tasks are converging to the paged state of the new function. And when all the functions are paged, the transition changes to 0, obviously. At the beginning, all the patches have to be cumulative and replace the previous one. Is it possible to avoid this now? But this is the default key patch behavior. Then the live patches could be disabled and removed. There is a reference here if you're more interested in the life cycle. I think for the project of introducing live patch in Debian, it's interesting to take a look to the release life cycle of kernel images in Debian. This is just a copy paste of the news in the tracker. And there is nearly one release per month, more or less. So this is a very high frequency. And this poses the question for how many kernel images we are going to support live patches, for example. And this is something to be discussed yet. We have thought about two possible ways of distributing the live patches, via Debian packages or via specific client tooling. There are pros and cons in both approach. Via Debian packages, well, the infrastructure is already there, so we can use it and probably could make our life easier. But the distribution could be slow. There is an important restriction because key patch requires the full source code of the target Linux, and if we want to support several kernels at the same time, this could make things complicated on the infrastructure side. We made a proof of concept here in this repository, if you're interested to taking a look on it. But we have decided anyway to go for a specific client-server approach. Why? Because in theory the distribution will be faster, and this is a feature important for livepatch. The concept of this is that the infrastructure and the tooling is to be built. So we are going, our plan now is to define all the requirements, or, design the tooling, and implement it, of course, and then provide it as a service. So we have to define the livepatch release lifecycle. We have to define the whole architecture. The formats that should be used for the source livepatch and the binaries. One important thing is what will be the workflow and the triage. We need to decide which issues warrant a livepatch. It is important to discuss how we can collaborate with other security teams and how we can with other teams, how we can contribute to them, how we are going to test it, and all the CI relating to this for reducing complexity, as been suggested by a dear friend. We are one of the requirements is to give. Let me a second. I guess it's here. Yeah, we are introducing We are planning to introduce dependency on previous packages. This means that for a specific kernel image, we are going to produce a sequence of live patches, and we are not planning to support removing one of them. There should be a sequence of them, and if you want to apply one of them, you have to apply all the previous ones. Yeah, so this will be kernel version dependent. We want to have the minimal as possible dependencies. Probably the users of these tools don't have something more than the base Debian system. We are deciding in which programming language we are going to use it. If we want to have the minimal dependencies, it should have to be or Bash or C or Perl. But maybe we could think about something else because the users will have something else anyway, some Python probably. The client tool must be able to tell the users where CVEs are going to be fixed with a specific live patch. We are considering the reproducibility of the binary live patches in the design. This is something very important. And of course, we must guarantee the security features as the integrity and authenticity of the binary packages that we are going to produce. This is just some discussion and drafts for idea. We are not going to implement the wheel. So, for example, this is an idea of a live patch binary package format that could have, for example, an extension DLP. Don't confuse it with the DPL. That will have some control and the data, and the control could include the kernel target, the specific kernel image for which the live patch will apply, the dependency that will be the previous live patch that should be applied before it, and the models included in the package. Of course, there should be. I don't see the same thing in my screen. Sorry. It should be accompanied by the crypto signatures to provide the security guarantees, security features. This is not the format. This is the ideas for the content that should be included in the source package. Well, the dependencies regarding the Linux image, regarding other patches, for example, and the patches. that will produce the models, and they must comply with a dep and enhancements procedure that is still to be defined. So what's next on our idea? Define a collaboration place for being able to discuss about the design and the requirements and etc. Consensus about the formats that we are going to use. Design the architecture, of course, implement it. And well, it is time for a couple of demos, or live patching, of course. So there is a simple demo. In this repertory, I have 6 files, 3 patches and 3 KOs. And I'm going to use key patch for them. Yeah, before that. So I'm basing one of these in the example that was found here in the example that comes from the kernel source tree that patches the command line proc show function with something different, of course. And I'm not doing that. I already did this part of this presentation in DebConf, in the last DebConf. I'm not doing exactly the same demo because it will be even more boring. But yeah. So this is the normal command line for the running kernel. This is deliberately I booted from an older kernel. This is this is kernel 6.190, and this is how it booted. And I'm applying this live patch. What? Yeah, sorry. So the transition has completed. Sorry. And Supercode is promising that DebConf 25 will be awesome. By the way, we are looking for support for the next DebConf. Sorry? And yeah, so this is a simple demo, and there are also a couple of light patches for actual CVEs. One regarding an invalid reads in the direct rendering manager, another about a user after free in Bluetooth. This is difficult to, this is not very visible, but I just have to keep patch load live patch CVE, for example. This, if I'm not wrong, yeah, this is the invalid reads in DRM. It's applied. I can take a look to the patches already enabled. So I have the simple demo and the CVE, and I can simply load another one. The user after free in Bluetooth. Don't worry, because if you didn't see the button, I will unload one of those. Yeah. So currently there are 2 live patches applied in the machine, the simple demo and CVE 2024 27398. And I can apply another one. This is very simple. Okay. Okay, and now I have the three live patches applied in the machine. As I previously mentioned, this should be available in the syskernel live patch tree. Oh, yeah, sure. where I've also found the live patches here and the status. So it is also enabled, but key patch makes the lives easier. Any questions so far?
Hi. So, firstly, there are a few things that go together. Firstly, Kpatch does a lot of the conversions automatically, as I understand it, but it doesn't do quite every possible transformation to a livepatch module automatically. Sometimes it requires human work. Also, there's very high throughput. If you put those two things together, it seems quite likely that somebody's going to make a mistake in the conversion process at some point just due to human error. What systems are available for making it possible to mechanically check that the result of applying a given live patch produces the same effective results as rebooting into a kernel with that same patch applied, if any? And is there anything that can be done in the way that we do this in Debian to make that process easier?
No idea yet. So, yeah, as I said, let's consider this is above, and this is the things that I have to study yet.
Fair enough.
I must clarify that this is in the very early stages of the idea. So, yeah. But help is, of course, welcome. If you want to collaborate, we'll be glad.
So the live patch service in Ubuntu is behind Ubuntu Pro, which means it's only available if you pay for it somehow. I have been digging. So I know it works internally because I'm in the team, but from outside there's no public thing, so there's no specification of the format, of the server, of the client. So is that also the result of your research? Can you maybe reuse some of it, or there's nothing to reuse because it's not public?
I haven't found anything public regarding Ubuntu, unfortunately. Yeah, the only public implementation that we found was the Gentoo.
Yeah, the Gentoo one.
Yeah.
Okay. And do you think that could be reused? That has some good ideas, or would you prefer to start from scratch, given it has been left over?
Emmanuel thinks that it could be possible to reuse it at some point, but I'm not that sure, especially if at some point we want to, for example, provide support for secure boot, and I would like to integrate it with Debian, and I don't know, I would prefer to have something more Debian related. Even if the final product could be used for derivatives, for example, yeah, I'm not that sure that we could reuse a live patch. And no. Yeah.
I think the last question is behind Ubuntu Pro because it takes a lot of time and it's really time consuming. So who would do the work of creating the live patches and publishing them? Because it is a lot of work to go through all of the CVE, find the one that are high vulnerability, create a live patch for it, test it, send it, publish it. It's a lot of work. So I didn't get which team is going to do that because it wasn't the kernel team, because it says you are going to collaborate with the kernel team of Debian? So
no, we said that this is to be discussed, how we can collaborate and contribute to other teams. For now, this is Emmanuel and me. And
so
one of the first things to discuss is where we are, the mailing list, for example,
between security
infrastructure,
team, kernel team,
and because we are consuming work done by both teams. For example, the kernel sec repository, most information for this, for the commits that fixes the CVEs that I show were found in the kernel sec. And okay. And so,
thanks.
Yes, kernel sec will tell you that, and also there's the upstream repository. I forget the name of it, which tells you that information. Now that there's the Linux CNA. Neither of those will tell you what's the most serious thing, what you should prioritize, and that I think is going to be, that would be a large part of that work.
Yeah, sure.
So Ben told us roughly how he would like to do reproducible kernel objects for lockdown. And I think I get how you can do reproducible live patching. And I also get how you can do secure boot live patching. But how do you combine all three?
The answer is no idea.
I'm not
for
sure
the moment.
It's technically feasible because we effectively want to have no private key authenticating kernel modules for reproducible builds, but that's precisely what you need if you want to do anything in lockdown. And you can't do reproducible signatures because everyone would be able to do them.
Yeah, I don't have an answer now. Yeah.
Industrially, one of the main use of live patching is industrial system, automatic system, like you have a Tesla and you want to live update your Tesla. So the question is, does live patching is compatible with real time? Because if you run a live patch and your Tesla is going straight, it's not really good.
So I'm checking. But I think Canonical provides live patch for the RT and for the real-time kernels. I need to double check, but I think that's something Canonical does in their live patch, is to propose this. I don't know how it works if you're running the Tesla. If it updates while you're driving, I don't know how the thing will behave, but I think it's possible.
Thank you. Thank you. I think we still have a few minutes for the last question. Last questions, actually. 5 minutes. Something like that. Anyone want to ask something to Santiago? Is coming from so far away? I think it's a wrap. 7 minutes? Okay. Do you want to say something else?
Yeah, thank you.
Thank you.
I personally would like to take Friction because my work on this has been founded by Friction. So thanks a lot. Yep.
Thank you very much. So we'll see you in 11 minutes with Arno. Okay. Thank you.